So this is actually, the idea is to provide identities to objects for the future internet with a fingerprint and a footprint approach based on physical unclonable functions and blockchains. So we start presenting the company. We are a team of successful serial entrepreneurs in different fields. We are building equipment for semiconductor industry, processes for materials in thin films, and new devices based on new architectures that we can achieve with our unique thin film growth process. So our core expertise is just micro and nano 4D printing of multifunctional thin film materials. Here we can see some examples of what we can do. Actually, we can pattern during the growth the material morphology, but also the properties, and embedded in a 3D growth process, all functionalities in a very complex way with a single step process. And this is very powerful because it allows us to address unique architectures for microelectronic, photonics, or other fields applications. So here we can see, for example, SEM scanning electron microscope pictures showing high-resolution dots with 500 nanometers on the left, color pictures due to interferential colors, or 3D printing at a more higher scales with hundreds of microns. And we can achieve all these features and these scales in a unique process in parallel. So what are thin films? Actually, for the students, thin films are sort of high-tech paints with dimensions between 10 nanometers and 10 microns, allowing integration of new functionalities, meaning value, onto a substrate, a chip substrate. It enables to develop new material properties due to nano-size effects, and it enables miniaturization of devices, as we have experienced with smartphones, for example, or computers. So it's a very added and pervasive key technology, enabling more functionalities, value, and quality of life with less resources and eco-impact. So the applications, actually, I said they are pervasive. Actually, most of the high-tech applications today rely on thin films, and they are really everywhere. Even in some devices like bulbs, light bulbs, LEDs that are replaced, light bulbs, or for smart windows, or more high-tech application you are more common with, like computers, smartphones, and so on. And they start also to be introduced in biotechs, for example. So what is interesting for us today is to deal with security for photonic applications. So our goal is to provide self-sovereign identities for objects. And for that, we have three technological assets. The first one is equipment that can provide additive growth for semiconductor materials with up to 450 millimeter substrates, 5 elements, and 500 nanometers resolution. The resolution could probably still be improved with more costly shadow masks, but this is actually our standard. We have also oxide materials that are unique materials because they can display most of the functionalities, if not all, available in the various industries, from optical ones, electrical ones, and so on. So they are very powerful platform material to provide new functionalities and integrate them on chips. And the idea is just how we can show here is just to make a sort of fingerprint, merging the functionalities of the QR codes with the fingerprint. And this is after just provides the identity for traceability and authentication to the object. And then we have developed a unique blockchain approach that is user-centric, holistic, semantic, scalable also to IoT, with strong interoperability and with really low human supervision, also to manage the codes and things like that could be managed directly by the object. So what are the societal challenges to address properly Internet of Things that is showing up and is getting more and more concrete in everyday life? So we are all familiar with the Internet. So in 2019, for example, it was a market of 500 billions per year. And this is just a picture showing what happens in 1 minute in the Internet. And so it's really pervasive in our everyday life. And it's a very powerful technology that change a lot, not only on our everyday life, but also on business ecosystem. With the new era 4.0, that is considered as a new industrial revolution, where cyber-physical system will come into the deal, into the processes, and they will assist in monitoring physical processes, create a digital copy of the physical world, make decentralized decisions and cooperate with each other and with humans in real time. Things are changing fast towards something new that will offer unprecedented opportunities. So it will improve work and cost optimization with improved speed, reduce errors, and enable logistic enabled by objects with potentially also big data real-time analysis. It will also enable business convergence with stronger agility to address new markets, strong interoperability, and the possibility to manage cross-disciplinary complex tasks easily. And this vision will strongly impart the next Internet, because today it's just the standard Internet with 500 billion US per year, but with new objects that will provide new data, it will just increase strongly what the future Internet will be, with also involving quantitative information, as we can start to see with Google Analytics, for example, semantic web also to organize the data, and it will also have to address the trust. So something that today is one of the main bottleneck in the Internet. So it will just involve new data from objects, machine-to-machine interactions, and it will be several trillions US dollar per year. It's just amazing what the next Internet will be. And it will be a huge share of the global worldwide economy. So what are the challenges? Counterfeiting, cybersecurity, identity usurpation, non-certified information, data sovereignty loss, lack of interoperability, and too many trust intermediaries. This has a huge cost in time, money, and when you fail, reputation. Just to provide some numbers, counterfeiting is between 500 billions and 1 trillion per year. It's a loss of legitimate jobs, that's millions. So it's huge impact on the economy and the employability of people. And cybercrime is even worse. It's 5 to 10 times higher than that, and it's growing at a pace that is simply incredible. So we have seen some features in the precedent presentation, but there are some other features at digital level that have also to be addressed, and they have to be fast and online. And this is how our solution can provide more value. So here it's a solution and intrinsic limit for fingerprints. So to achieve traceability and authentication for objects and the data they provide. So I will not go in detail, but just today what we have to address the Internet, it's cheap, but It's established, but actually it's not really adapted to go fast. Reading is expensive in time and in resources to have readers or experts that just can say that it's authentic or not. In the future internet, it has to be managed directly by the objects. So cyber physical system will have to do it, and these objects, one of the most interesting approach are physical unclonable functions that enable single product authentication, data authentication, cryptographic enabling tools. It's not based on software differentiation, that is a main asset, and it's more energy and computing efficient, so it can provide security to low value objects. There are still some limits. I will not enter too much on it, but normally you have to make an enrollment of the challenge response pairs just to check the fingerprint and to be sure that you claim what you are, who you are. And also, there are lack of stability versus cryptographic tool. At the limits or intrinsic limits of footprints, there are many. So emails that are probably the most used one. So it's a mainstream solution, but you have no VRM tools, so you cannot control access your data. You have privacy concerns. Obviously, you have a loss of sovereignty because the platforms are controlled by someone else, and you are just an explosion of number of accounts. So also with a bookmark on the internet, you have similar problems. And also with standard ledgers like banking or things like that, you have strong trust, but it's expensive. You have poor interoperability between different platforms. It's slow, lack of standards. So for governments that want to exchange information of the citizen, it's very difficult, and you cannot scale to large systems like IoT. Blockchain are provided to have alternative models with no central authority, with self-sovereignty, but this can be also a problem if you experience a problem, nobody there to solve it. Poor flexibility to manage privacy, resource expensive, slow, cannot scale to IoT, and poor interoperability because there are too many platforms available. So main problems, it's usually now it's complex, slow, and expensive, poor customization. Security is a main issue. Fast obsolescence, Thales mentioned it. And there are a lot of placebo technology or things that are not anymore, that are obsolete, and then you still think that it's suitable, but it's not anymore. And this is very time-consuming and requiring a lot of resources just to manage that. And then you have emerging unmet needs for Internet of Everything, like always mentioned, interoperability between different categories of people or objects or governments or companies, data trust and certification of information, value problems with a digital twin. You can claim values that are not effective. Organized information is a huge problem with big data, for example, and you have more and more problems with data governance and sovereignty. Actually, you don't know who own your data and what they do with that. So today, nobody can deliver a suitable global solution. And this is mainly because objects can be used as offensive weapons in cyber warfare, but not as defensive ones. And so this is what we are trying to provide. And so more than that, that will be probably place for a new 5.0 revolution about trust, because today trust volatility in the internet is a main pain. And and you can see it. You cannot know anymore who is trustful and who is not. And sometimes you put your trust in something that should not. And this is a huge issue, because without trust, there is no value anymore. And so you cannot keep safe your assets and your savings. So this is, for me, the next revolution that will have to be addressed. And this is what will make a transition from the technology, knowledge society to an intelligent and trustful society with the fourth and fifth revolutions. So self-sovereign identities, also for objects, for me, are needed, and they should address both fingerprint and footprint approach. So this is what we are doing. Our solution, we provide PUF blockchain combo that is still under development, but it will provide self-sovereign identities to objects to enable traceability and authentication at physical and digital level, improve cybersecurity with totally new approach in cybersecurity with primitive generations, and a blockchain footprint management model, a vendor relation management, actually enabling you to know exactly what the information is available on you or the objects, and how it is shared between different partners. So this will enable smart and trust-enabled objects. And if you can do that, it means that the object will not be able only to make low added value tasks, but they will be able to replace people in many high added value tasks. So how it consists, our PUF is actually a pattern Oxides in films. Here I'm showing optical properties at different scales, down to 500 nanometer scale. So we can have overt, covert, forensic properties, but also what we called ultra covert approach, because we do not have only one property that you can read. We can have a multiplicity of approaches. And so if you don't know what is a reader used to validate your solution, it's more difficult to counterfeit. So here, for example, we can show in small a the color and white and black recorded image of one of a PUF, optical one, with different wavelengths on the right, and you can see that the fingerprint is completely different. And so this is a variable optical feature that changes as a function of the wavelengths, and so it's not fixed once for all. The topography we can play on. We can play also on electrical properties, and most of the properties that can be addressed by Oxides in films, and with a very high level of miniaturization, meaning that you can have more information. So this way we can provide objects with their own fingerprints, with a cost-effective mass production of all different PUFs, actually billions of PUF per equipment per year. And the properties are more complex than anything else, because you have several properties. It's a multidimensional matrix, actually, not based on the binary code, but multi-value code that is very powerful. Also, it cannot be cloned and rolled at digital level, because in a square millimeter, we can have more information than what is recorded today with all computer on Earth. So this is still something we are assessing, but we have found a way just to provide so huge quantity of information in our etiquette that they cannot be digitally copied, and so you always know where the keys are. Even if someone gets a key, he cannot copy it to some software database, and so this is very powerful. Also, we have a physical database that is provided by a twin PUF, so we do not have security issues, digital database. And finally, we provided embedded cybersecurity and cryptographic tools managed directly by the PUF. With an overall blockchain we have patented, we have also a very strong security with a bottom-up approach for individual objects. So it's not a platform that secures all the objects simultaneously, it's individual objects. And so you have to crack for each object the protocol. Also, we support enhanced smart contracts. We have very strong business agility with a bottom-up approach for full interoperability, certified and organized information with semantic and holistic approach. We can scale to a very large number of objects. We are fast, actually unlimited transaction per second. We can keep user sovereignty and governance over own data. So because we have no platforms, they deal it for us. And we have a native privacy compliance with GDPR that is in the solution. So conclusion and outlook. So there are two problems, authentication of physical objects and data, and scalability to internet and large systems. In comparison to what Gemalto and Thales provided before, where you have just an external reader that can authenticate an object and or a person, actually we embedded it on a chip, and so we have an integrated reader, and so we can go fast and address the challenge of the new internet. And this is one of the main features, because even if the etiquettes today available on the commerce are cheap, if the reading is slow and expensive, it will never be suitable to address properly the future internet. So from hype to unprecedented societal challenges, actually we have seen that the bitcoins or things like that for blockchains or things like that were just a huge hype with a lot of speculation on that. I believe that with smart contracts and new approaches, smart blockchains could really completely provide a new solution and to do real business and something that will not only be a speculation, but really provide something that is really needed in our society, with direct machine-to-machine exchange of data, scalability to large ecosystems, reduce intermediators that are just a pain for trust and for to achieve scalability of businesses in many cases, or just to find new customers, provide a user-centric management tool to avoid loss of governance and sovereignty over data. And this could also provide new bottom-up approach to trust management for totally new societal models. It's just something more than just business. It can completely change the society in which we will live tomorrow. So in the end, we will provide a competitiveness without losing sovereignty and privacy. That probably is a main challenge in the internet today and in the future. Thank you very much for your attention. If you have questions, you're welcome.
Thank you very much, Giacomo. So let us start with the first question. Evgeny Rudako, student of the Master PSRS, has a question, probably. Evgeny, we are listening to you.
No voice.
Yes, Evgeny. Evgeny? So perhaps we don't hear you. So perhaps you have your microphone off. Please check. So let us commute to Mohammad Moazzam. Mohammad, are you here for a question to Giacomo?
Yes.
Okay.
I have a question for blockchain, are you using some kind of third party like Ethereum or something like that, or have you developed your own blockchain platform?
So for now, I was saying it's still under development. Actually, we could use any blockchain. It's not at this level that our innovation is. It's just more as the architecture of the smart contracts.
Okay. In that case, aren't you distributing all data to the basically your every node will have access to all of your data? Will
No,
it be centralized?
no, but I will not discuss that because we are still we have already a patent, but we are still patenting. So I will not answer this question on blockchain. Sorry.
Okay.
So Giacomo, a question from Evgeny, who has a problem and is muting. So the question is, do you use machine learning for your solution, or does it make little sense for your tasks? And if yes, what of the role of it? What is the role of machine learning if you use it?
So for now, we do not have machine learning. This is beyond the scope of our solution. But I think that the solution could provide very interesting solution for artificial intelligence to manage the data that are gathered by objects and to qualify and certify the objects that are gathered through a full protocol of the footprint on how they are gathered. And then this could be it's not really machine learning, but I think it could, once you can have this aspect in artificial intelligence, it can open new ways just to provide a new protocols for machine learning. But we are not working on that, actually. We're too small.
Okay, thank you, Giacomo. There are many things to do. Pratibha Sharma, do you have a question? So Pratibha, from Pratibha, Pratibha said it was a great presentation. There are so many companies doing similar works, she said. So what are the key features that make your company different from others that would interest customers and clients to your company? This is the question from Fatima.
So actually, as I try to present, we have solutions that are completely different. We have orthogonal technologies that are still compatible with mainstream platforms of production. So the possibility to integrate very complex materials on a chip is unique. The possibility to do all different hardwares with the possibility to replicate in parts the information for a twin puff that act as a database is absolutely unique. All the competitors are based on pure random patterns. So it's something that cannot be addressed by competitors. And with blockchain, actually, it's so unique because it's a bottom-up approach and not top-down. And so it can be adapted to whatever business and needs with very easy customization. And so these are the main assets.
Mm-hmm. Yes, it is a good question because PUF was born with optics and photonics, and then electronic system will develop PUF, and it's a comeback, I would say, from optics and photonics with PUF. So, is there any question from the chat? No other question, so we can save time for the roundtable. Thank you very much, Giacomo. So we try to do our best with respect to the calendar, and we can have you during the roundtable.
Yeah, thank you.
Okay, thank you very much, Giacomo.
Bye.
See you later.